Okay, for this session, this is session number 5. We will talk about retrieval evaluation. So the objective of this session is to discuss about how do we evaluate the retrieval result that we get from the ranking system or the ranking computation that we get. Okay, in the previous lecture, we talked about set-based based on more than one index retrieval. And before that, we talk about TF-IDF, which is mostly discussed about a single or one index based retrieval. Okay. So for this lecture number 5, we will look into how do we evaluate the retrieval result that we get. Okay, so since every one of us have different background, depending on how much we read, depending on how much we are exposed to certain technology, certain concept, so different people may have different perception, even if we are given the same result using the same query. So you may have different opinion about which one is more relevant to you. Okay, so because of this different opinion, we need to have some kind of metrics that we can use in order to evaluate the retrieval result that we get. Okay, so we need to have some metrics. So why do we need this? Because we need to determine how well is the system performing, how good they are, and also we use the metrics in order to compare the performance of the IR system. Because you may build your retrieval system using different method or different process. Okay, so we need these metrics in order to compare the performance. And this retrieval evaluation is very critical, and this is part of the component in any of the IR system. Okay, so today we will learn how do we evaluate the quality of result that we get. Okay, so before that, we need to look at some of the concepts that we have. Suppose we have a set of D document. Okay, a set of D pre-selected document, and then we have the information that you need. Okay, information that you need, and then you must have some way of judging to associate the pre-selected document with the information that you have. So this is based on your background knowledge, and then you will determine which document can be associated. So this is you. So this is done by the expertise law. Okay, so provided that you have pool of document and this is what you need, and then you must be able to associate the information with the document that we have. So what we have here is that we need to relate this information with the document where IM belong to the information and DJ is belong to the document. So if they belong to that particular, for example, if the document is relevant, then we say that this is 1. If the document is not relevant, then 0. Okay, so we like marking them 1 or 0, whether they are relevant or not. Okay, in order to do that, we have two ways. The first one is called precision and recall. And the second one is we evaluate based on a single value summary. Okay, so we will look into this too. Okay, how do we define precision and recall? Okay, consider the information requested is I just now, and we have a set of relevant documents for that particular I, and this is R, and A is given to you. So, meaning that we have the bigger circle here correspond to the all of the document, and only a small part of the document that is relevant with respect to the I. Okay, but given to you is this one. This is the answer. So only a small portion that we have, which is overlapping with the relevant document. So what we want to do is we want to have larger area of overlapping. Okay, so we want to maximize this area. How do we move this A to cover more of the relevant document? Okay, but before we can do that, we need to measure how is the performance of the retrieval system that we have. So this is the intersection of relevant document and the answer that you get. Okay, so we will use this concept in order to describe precision and recall. Okay. So for the first one, recall. Okay, recall is the fraction of relevant document which has been retrieved. So basically, you want to know how much is the overlapping with the relevant document with respect to the size of the relevant document. So this one is given 10 relevant document, how many that you get to retrieve, how many that you manage to recall. Okay, so if X is 5, that means you only can recall 50% of the relevant document. Okay, and the second one is precision. So precision is the fraction of retrieved document which is relevant. So this one we look at here, pembahagi dia. So this one we want to know how much, how many portion of the answer which is relevant. So if you have 10 documents that return to you, and only 5 of them relevant, so we say that our precision is 50%. Okay, so this is the size of your written document or answer, and this is the size of the relevant document. So those are the differences between recall and precision. Okay, so how do we actually compute this? So what we want to do is we want to plot a curve of precision versus recall, because this one will tell us the performance of the information retrieval system. So we need to know what if the recall is 10%, how much is the precision? If the recall is 20%, how much is the precision, and so on. Okay, so we need to plot this curve. Okay, so let's have this document. For example, we have query number 1, and query number 1 has all of these relevant document that we have. So we have D3, 5, 9, 25, 39, 44, 56, 71, and 89, 1, 2, 3. So we have around how many? 10 documents that are relevant with respect to query number 1. Okay. But when we use a new IR algorithm, so they give us this result. And the one that tick here or mark here are all the relevant document with respect to query number 1. Okay. So from here, how do we plot the precision and recall? Okay. So we need to go step by step. Okay. So okay, the way we do it is that we mark at of each of the relevant document, for example, here. Okay, what is the precision at this moment? At this point. Okay, how many you return here? How many you get? What is the size of this? 1, right? And how many of them are relevant? Because we only have 1 and they are relevant, so this is 1. So at this point, the precision is 100%. Okay. And what is the recall? We know that we have how many relevant documents, which is this, right? 10. So we have 10 relevant documents, but only 1 we retrieve. So this is 10%, right? Okay. So we do again here. What is the precision here? Anyone? Jangan malu jawab. Test your knowledge. What is the precision? And what is the recall? The recall here is because we have 2 at this point, so we have 2 over 10, right? And then the precision will be 2 over 3, because this is the set of answer we get. Okay, let's do this one. What is P at this point? What is P? So how many documents we have at this point? Okay, 3 over 6. Very good. 3 over 6. Because we have 6 documents, right? This is in this order. Okay. And what is the recall? What is the recall? Okay, so recall is 3 over 10. Very good. Recall is 3 over 10. Okay, so we will keep continue doing at all the position where we know that the document is relevant with respect to the query that we have. So over here, what is our P? What is the precision? And what is the recall? What is our position here? Okay, 4/10 and 4/10. Okay, because at this point we have how many answers we get? We get 10, and 4 of them are relevant. And for the recall, we have 10 documents, and only 4 are being recalled. Okay. The last one here. What is P? What is the precision? 5/15 and 5/10. Okay, so very good. So what we want to do is we want to list all the precision and recall. Okay, so up to this one we have all the value. So this is number 1. This is for document 3. This is document 25. This is document 9. Okay, and this is document D56. Okay, and in the previous slide, this is for document 1, 2, 3. Okay, so with all this value, how do we plot them? So basically, we will run this 0, 10, 20, 30, 40, and so on. So this is our recall. So for each of the value that we have, like 10, example just now, the first one is the recall is 10, right? So the precision is 100%. Then 20%, this is the precision. 30%, this is the precision. 40, 50, and so on. So when we table the result here, okay, since we do not have any more information here, so we cannot do the rest of this. So this is 0. Okay, so basically what we have is this one. Okay, so this one is put to 100 because of this value we put here. Okay, so when we plot, we will have this graph. Okay, as you can see that what we want to have is we want to have more or less like this. We want to extend the area under the curve. Okay, so that means we can say that a system is better if area under the curve is larger, right? Area under the curve is this one, keluasan di bawah graf itulah. So we want to maximize this. Okay, let's take a look at another example here. Okay, how many documents we have? With respect to query number 2, relevant document only 3, right? So when we test our IR system, and they give us this. So what is the P and Q? No, P and R. What is the P here? What is the precision and recall at D56? Okay, so 1/3 and 1/3. So make sure the rest also know what's going on here. So at this position, what is P? What is P? And recall. Two over 8 and 1/3. Yes. So our position is 2/8, and this is 2/3. And last one. This is, the position is 315. Recall is 3/3, right? Okay. So based on this value, okay, so okay, bear in mind this one. Plotting is very important here, because over here is the recall is 1/3, right? The recall here is 2/3. The recall here is 3/3. So that means at the mark of 30%, 60%, and 90. So that means at the mark of 30%, 60%, and 100%. Okay, we have this value and this value and this value. Okay, because the recall here is 1/3, and the recall is 33. Okay, for this one, the recall is 2/3, which is 66%, right? And then over here is 1. So basically we are looking at the number bullet here only. So whatever value we have here, we fill into the top. Whatever value we have here, we fill in here. Okay. So just now we have what? The recall is 53%, 1/3. And then 66, which is here. And then next one is 100. So we mark here and then we copy. We mark here and copy. Okay. Okay, this is, for example, we are talking about the same system here. This is for RQ2. This is RQ1. So this is the graph for the query number 1. This is the graph for query number 2. Okay, so we can use up to 10 query, and then what we want to do is we want to take the average, and then based on the average we can replot again the graph precision and recall. Okay, so we have 1 and 2 now. So what we want to do is we want to measure the average. So this is based on the number of query that you have. So what we want to do is we want to look at what is the average position given the number of query that you have. Okay, so this is the average position at the recall. So if we have these two, so if we have, this is the result for query number 1, this is the result for query number 2. So we take these two, we add up, and we take the average. So similar to the rest of this number, we take the average and you get this. Okay, so once you get the average of this, then you can plot your recall precision graph. So the final one will give us the average performance given all the query that we have used in order to test the IR system. So notice that when you want to test the system, we need to use a few questions, and then we need to know what is the recall, what is the precision. Then based on the 10 question, for example, we take the average, and then we get the final average recall and precision. Okay. Any question? Okay. So we mentioned just now we can use this matrix to compare, right? So which one do you think is better? Given we have two systems here, so we have the blue and the black one. So which one is better? I remember just now we want to maximize area under the curve, right? So to see the overall performance, we need to look at what is the area under the curve for the blue one, and also area under the curve for the black one. Okay. So this is how we compare the performance of the IR system. Okay. Let's do this one. That is your assignment later on. Okay. We move on to the second one, which is single value summary. So this is using the same matrix, precision and recall, but this one is only at 1 point only. They call it single value summary. Okay. So the average precision recall curve is a standard evaluation matrix for all the system that we have. However, it takes time to compute them. So they say, okay, why not we just pick 1 point only, and then we will use that one as our reference. Okay. So they use this, what we call a single precision value. So you don't have to compute all the precision and recall for every document that you have, because it is time consuming. Okay. So they will say, okay, sometimes they will ask, okay, what is the precision at 5 or at 10? So they say, they just pick a random number only. They don't want to evaluate every part of the document, but they will specify what is the precision and recall at certain point of your document that we have. Because normally we will given a list of documents, so we just check a few points only. So for example, like this, given the list of 15 results that we get, so our query will be, okay, what is the precision at 5? The precision at 5 will be here. Okay, which is P is equal to what? What is P equal to? 2/5, right? And what is P at 10? So P at 10 is here. So this is 4/10. Okay. So this one is much simpler. They use a single point entry in order to decide what is the precision and recall at that particular point. Okay, so this is how they compute area under the curve. Okay, so they call it mean average precision. Okay, if you look at the formula here, let me. Okay. So if you look at here, they consist of this map means average precision is actually taking the average of the precision for all the document that we have. Okay, so we are looking here, the first one is N. So what is N? N refer to number of query. Okay, number of query. So meaning that we will take the average. And also we are looking at, for each of the query, we will look at the person number of relevant document that we have. Okay, so QJ is number of relevant document for query J. And basically we are summing up the precision value. Okay, how do we apply this formula? Okay, for example, like this. So area under the curve can be represented using the means average precision. So basically we are taking all this value only. Oh, sorry. Okay, 1, 2, 3, 4, 5, and the rest is 0. And 10 here referring to number of relevant document. Okay, which is this one. Okay, this is only for query number 1. Okay, any question? Okay, if we look at query number 2, yeah, same thing here. Okay, query number 2 would be what? If we go back here, what is the mean square error here? No, means average precision for query number 2. So that means you are taking all this and divide by how many? In this one, we have how many relevant document? We only have 3. So we will take all this, sum up that value, divide by 3. Okay. Okay, to make it clear, let's go over one example here. This is more interactive. Okay, so the blue one is relevant document with respect to query number 1. And we have the ranking according this order. Okay, so those are the recall and precision. Okay, so those numbers are recall and precision. And if we use the query number 2 and query number 2 has this ranking, and these are the recall. So what is the means? No, the mean average precision that we have here. Okay, for map 1, we take what? All this precision and divide by 5. Okay, and then for this one, we take all the precision and then we divide by 3. Because the 3 here are referred to what? Refer to number of relevant document. So map all will be divided by 2 because we have 2 query. So let me get the formula again here. Oh, the formula is up here. The formula is up here. So basically you are summing up all the precision for that particular query and you divide by the number of relevant document, and you do it for how many query that you have. Let me go back to the definition here. Yeah. So number of query. So N is number of query. QJ is number of relevant document. Okay. So if we have 3 query, that means we have map 3. So we just add map 3 value into the map all and divide by 3. Okay. Any questions so far? Okay, Joshua. Yeah, I remember you. Okay. For the R precision, so this is another matrix that we use. So this is the combination of R and P. Okay, for example, like this, they're looking at the number of relevant document for a given query. Okay, so the idea here is to compute the precision at the R position in the ranking. Okay, so for example, this is the precision at recall A. Okay, so this is the precision for algorithm A for the I query, and this is the precision for algorithm B. So they just take the difference between these two. Okay. So the graph is more or less like this. Okay, for query number 1, B is better. For query number 4, depending on the formula. Okay, this is A is better. This is A is better. This is A is better. Means bigger. This is B is better. Because the formula here is that they look at the precision for algorithm A at I query at this position. And this is for the B. So they just want to take the differences between these two. Okay, so in most cases, algorithm A is better because they have higher precision. Okay, So we can say that in this case, algorithm A perform better for 8 of the query, while algorithm B only works 2. Okay, because the higher is the precision, the better. Okay, last one, we have this. Okay, the most important metrics that we have in this session, in this class today is the precision and recall, right? So there are two metrics that we are looking at. So they have introduced F measure that combine these two. Because what they want to do is we want to maximize the recall and also want to maximize the precision at the same time. So imagine that if this is 1, this is 1, okay? And the whole value will be 1, right? So F measure take into consideration the recall and precision at the same time. Okay, so whenever recall and precision is higher, the value for F measure will be higher. Okay. Okay. So for example, let me give you. So basically, at a certain position, we just have to mention about the recall and precision, and we just plug in the number, and we get the F measure. Okay. So it says that the harmonic mean F assume a high value only when both recall and precision are high. So only when you have recall 100% and precision 100%, then you get this one to be 1. Okay. But sometimes you get recall low, sometimes you get precision high, sometimes you get recall high, sometimes you get precision low. So that's why in order for us to get the best combination is we need to maximize the F value, the F measure. Okay, to maximize F require finding the best possible compromise value between recall and precision. Okay, so this is depends on a particular position in your ranking. This is your exercise and so on.